All right, physics students, this is homework number 5, and I'm just going to go through a couple of the problems on here just to show you some examples. So question 1A, it says, calculate the intensity of the sound waves from an electric guitar's amplifier at a distance of 5.0 meters when its power output is equal to each of the following values. So I'm just going to do A here, and for A, the value of the power is 0.25 watts. And the question says that the amplifier is at a distance of 5 meters, so that's D equals 5 meters. And the question is asking what is the intensity, I. All right, so we need an equation here. Now, first of all, in the equation, it refers to D as being R. And again, that's the radius of the sphere of sound that the amplifier is making. So it's probably 5 meters. On the other side, you'd experience the same intensity. But D and R are the same thing. Do not cut D in half to find out what R is. So the equation is I equals P over 4 pi R squared. And from there, we can just substitute our numbers in. So we go 0.25 watts for P, and then 4 pi times 5.0 meters squared. And probably the biggest mistake I see on problems like this is people forget to do that square. All right, so I'm going to get the calculator out here, and we'll go 0.25 divided by 4 times pi times r, 5 squared, and I get 0.000795, so that's going to be 7.95, we'll say 96 times 10 to the minus 4th. And the units are watts per meter squared. All right, moving on to number 3. Okay, so for number 3, it says if the intensity of a person's voice is 4.6 times 10 to the minus 7th watts per meter squared, so let's write that down. I equals 4.6 times 10 to the minus 7th watts per meter squared at a distance of 2 meters, so D equals 2.0 meters, and again, that's going to be R. How much sound power does that person generate? So the question here is, what is the power? And so for this one, I'm going to use the same equation, I equals P over 4 pi R squared, but we want P all by itself, so we're going to multiply both sides by 4 pi R squared. Let me rewrite that here. P equals I times 4 pi R squared. And then we'll just substitute the numbers in. So 4.6 times 10 to the minus 7th watts per meter squared times 4 pi times 2 squared. And again, let's get the calculator out on that one. So 4.6 to the negative 7th times 4 times pi times 2 squared equals 2.3 times 10 to the minus 5th watts. Number 5 says the power output of a tuba is 0.35 watts, so P equals 0.35 watts. And it says that at what distance is the sound intensity of the tuba 1.2 times 10 to the minus 3rd watts per meter squared? So I equals 1.2 times 10 to the minus 3rd watts per meter squared. And this is our equation. I equals P over 4 pi R squared. We want to solve for R, so we need to get that by itself on one side of the equation. So I'm going to multiply both sides by R squared. And I'm going to divide both sides by I. And so then what I have is r squared equals p over 4 pi I. And again, I don't want r squared, I want r, so I'm going to take the square root of both sides. And so I have r equals 0.35 watts over 4 pi times 1.2 times 10 to the minus third watts per meter squared. And the main thing here is just, keep track on your calculator that you're doing the operation correctly. So I'm going to go the square root of 0.35 divided by, in parentheses, 4 times pi times 1.2 to the negative third. Hit parentheses again. And I get 4.8 meters. All right, let's take a look at page 416. Page 416 is a conceptual type thing, so I'm not going to go through every single question on this, but there are a couple things I want to point out. So number one, on page 416, it says when the decibel level of traffic in the street goes from 40 to 60 decibels, how much greater is the intensity of the noise? And if you watch my notes from yesterday, every 10 decibels is 10 times the intensity. So if I go from 40 to 50 decibels, that is a 10-time increase in intensity. Okay, and going from 50 to 60 decibels, that is also a 10-time increase. So if I increase by 10 here and increase by 10 here, that is a 100-fold increase. So every 10 decibels you go up, you're multiplying the previous intensity by 10. It's a logarithmic scale. Number two, if two flutists play their instruments together at the same intensity, is the sound twice as loud as that of either flutist playing alone at that intensity? Why or why not? So again, here what's happening is you've got two people playing the same instrument, the same amount. So now you have 2 times the intensity, but that is not 2 times the decibel level. If it was, let's say they were playing at 60 decibels, having 2 of them would not, having 2 of them would suddenly not make it 120 decibels, because that would be 7, 8, 9, 10, 11, 12. That would be 10 to the power of 6. That'd be 100,000 times louder than this right here. So intensity and loudness are related, but they are related by an exponent rather than by just a direct proportion. So twice as intense, not twice as loud. All right, number 3. The tuning fork consists of 2 metal prongs. Looks like that. And it vibrates at a single frequency. So what will happen if a vibrating tuning fork is placed near another tuning fork of the same frequency? So here, if you strike this one and it vibrates in and out, it will cause this one to vibrate in and out as well, because it will resonate. It'll be driven or pushed by those sound waves because it's hitting it right at that exact natural frequency. All right, number 4, a certain microphone placed in the ocean is sensitive to sounds emitted by dolphins. To produce a usable signal, sound waves striking the microphone must have a decibel level of 10 decibels. If dolphins emit sound waves with a power of 0.05 watts, how far can a dolphin be from the microphone and still be heard? This is just a distance question. It's like one of the ones on the previous set of problems I just showed you. And then number 5, which of the following factors change when a sound gets louder? Which change when a pitch gets higher? So that goes to your understanding of pitch and intensity and frequency. So I'm gonna let you figure that one out on your own. You can look at the key.